titled my talk with the development of technology for the exploration and harvesting of the deep ocean minerals. Some of you must be already wondering why I use the word harvesting, because we don't like the word exploitation. It has some wrong connotation. So we use the word harvesting. Exactly, we are not going to reproduce actually what we are taking out, but that is actually the idea that we have to not only take out, but we have to really again regenerate these resources. That's the idea behind this. This is the outline of my talk. I'll be going into brief history. Later, I'll be introducing you to the deep ocean minerals, and then how do we survey and sample these things, and what is the technology development that is required in world scenario. And then we go into Indian efforts like a case study. And then we will discuss briefly about future work. Then I summarize my talk. So we always hear that 75% of the or 70% of the earth is covered by oceans. It is not mere cliche. Actually, it means that only 25% or 30% of the land is available to us. In that, habitable land is only 71% of that, really 30%. If you see that way, only 1% of the land is available for the mining, terrestrial mining. And we have been using and abusing this land for many thousands of years. So we are at the end of the tether now. So, but imagine if 1% of the land can give you so much, the covered one, that 30%, how much can it give? So such are the riches that are available to us in the ocean, still untapped. So if you see the distribution of the minerals in the world, you can see the unfairness. The poorest continent in the world has the richest abundance of these minerals, but that is a high enemy. But these are not going to last forever. Some of the minerals will be lasting for maybe a few decades more, but some of them are going to get exhausted very soon, maybe in the period of some decades. But what are the elevating factors? How can we overcome this problem? We can do more exploration in the sense that we can find out where more areas of this abundance of these minerals can be found out, or we can have better technology to reduce the consumption as well as increase the efficiency of production, and we can reclassify also. We can there are some reserves and there are some resources, so we can actually, with a better technology, we can call we can upgrade these resources to reserve status. Okay, but if all these things, ocean mining looks very imminent. The question is whether we have to. No, the question is when and how to do it. Okay, this is actually for those people who know about science fiction. Jules Verne long back predicted in 1870 itself that ocean depths there are mines of zinc, iron, silver, gold that would be quite easy to exploit. He was right, but he was not right about easy to exploit. So there is no one way of classifying the ocean minerals, but this is my way of looking at these ocean resources. They can be living, they can be non-living, and in the non-living again, they can be renewable and non-renewable. And today we are going to talk about minerals that are actually available, basically seabed minerals. I'm not going to talk about the dissolved minerals. So seabed minerals can be oil and natural gas, even gas hydrates, diamonds, polymetallic nodules, cobalt rust, and dissolved minerals can be salts, uranium, and other metals, which we are not going to talk about. And where are these available? They are available in the ocean, obviously, but ocean can be it can be actually broadly divided into EEZ of the nations and the common heritage of the mankind. So EEZ up to 200 nautical miles from the coast. It can be even extended EEZ also is now talked about. But the other area is actually called high seas, and there the land that is actually the seabed actually is called the area, and it is actually the common heritage of the mankind. But United Nations International Code Authority can allot these areas to the nations. So these are the seabed minerals of our interest. One is the gas hydrates, which occur at anywhere between 1,000 meters to 3,000 meters depth, and 50 meters to 500 meters below the seafloor. And they are rich in, I'll come to that point later. Then the polymetallic nodules, which occur in the abyssal plains at around more than 5,000 meters water depth. They are rich in cobalt, nickel, and manganese. And cobalt crust which occur on the sea mounts, that sides of the sea mounts at around 2,500 meters water depth. And finally, polymetallic sulfides, massive sulfides, which occur at the ridges and where the continental actually the tectonic plates meet. Actually, that in that crevices, the hot magma tries to come out and water tries to seep in, and the steam that is generated, it brings out the minerals from the earth crust to the that seabed. So gas hydrates, actually, as I told you, they occur in the sediments of the ocean or in the permafrost regions. Each cubic meter of gas hydrate, it's actually a crystal containing water and methane gas, and it can release 163 cubic meters of gas. So India has a large potential of these things. Whether they are the potential future energy, that is a question to be addressed. Second one is the polymetallic nodules. As I told, they are actually rich in cobalt, nickel, manganese, and even iron. And they occur at around 5,000 meters water depth, especially in Pacific and Indian Oceans. And they look like potatoes, around 10 centimeters in size in average. And they grow, it takes millions of years to grow. They are actually two-dimensional minerals lying on the seabed. Okay, so India is considered a pioneer investor by the International Civil Authority, United Nations, and in 1987 we have been given this status, and in 2002 we have signed an agreement with them where we got around 150,000 square kilometers of land in the Indian Ocean, that 30 degrees to 10 degrees south after crossing the equator, and these are rich in manganese, cobalt, nickel, and copper. Around 380 million metric tons of these nodules are available for picking. Similarly, this is the hydrothermal sulfides. They are available at around 26 degrees south in the southern Indian Ocean. They are rich in, again, the sulfides of this iron, copper, and zinc, and also to some extent in barium and calcium. And you can see this is a triple grid junction at around 26 degrees south. We have been given around 10,000 square kilometers by International Civil Authority. And cobalt crusts, of course, they are actually on the sides of the mounts. They are not exactly 2D minerals. We have to scrap them out and we have to cut it out actually. So, but why we can't, how difficult it is to really harness or use these resources, because it's more difficult than the terrestrial ones. For this audience, I did not tell how difficult it is to conquer the inverse space. These are the difficulties in more dynamic medium, hydrostatic pressure, around 500 bar, it is at 5,000 meters. And finally, there is no electromagnetic communication. So you don't know where you are going. You don't have any communication with the mothership without the cable. If you have the cable, then drag is very high. So with all these difficulties, there is no other way. We have to venture into the ocean for our future needs. So these are the components of the exploration. First, you have to survey whether they are there or not. And then we have to sample and see what is the abundance and what is the grade of the minerals. Environmental, whether it is safe to or how badly environment will be affected by removing these minerals. Then exploratory mining, then commercial mining, and then we have to close down and we have to clean after ourselves. And in the survey techniques, there are different kinds of surveys: seismic, acoustic, geophysical, and imaging. In the seismic survey, this is mainly used for the oil and natural gas. There are two things. One is reflection by and another is refraction. There is a source, seismic source. It can be air gun or some explosive source or something like that. And the receivers are towed behind, and the layers of the seabed are studied for the minerals. Next one is acoustics. You can see this is typical echo sounder. You send acoustic beam and you study the reflection. It can be a single beam, like a searchlight actually, but it takes a large time to cover this area. But if you have multiple beams, it is called multi-beam. And next one is side scan. This is used as a camera actually, like an acoustic camera. The sea bottom is actually imaged, and there are some special kind of sonars which study the sea bottom also. But how do you take them to the bottom? You need some kind of vehicles to carry these search tools to the bottom. So there are different kinds of vehicles. Again, we can classify them into manned and unmanned. We are not going to talk about military submarines, but mostly India is concentrating on the unmanned submersibles, and we are soon going into the manned submersible. The first of its kind is actually, the first of this kind is actually a tow body which can be towed behind a ship, either with a umbilical cable carrying the power and the signals, or just a rope with the recording devices on the tow body. We can put as many sensors as you want, like sonars, collectors, everything. Next one is slightly advanced version, that is actually a remotely operated vehicle. A long cable is there which actually allows us to drive, supply power and drive this robo, and it can do exploration as well as intervention. Next one is autonomous vehicle. This doesn't have the cable, but it can work on its own, but it has to be pre-programmed. You don't get to see what it is doing or what it is seeing. You only, once it resurfaces, you can download the data and the images. So, but now we have surveyed using surveying techniques, but how do you sample these things? There are different sampling techniques called grabs, dredges, and corers. Grabs are nothing but literally they grab what is there on the seabed. You can see this is a selected Van Mien grab. You can lower it with the cable, and when you pull it, actually this bucket is closed, and the these things are grabbed, minerals are grabbed in this one. But there are some things called boomerang grabs, which are very well known to our pioneers of NIO Goa. They just go down without a cable, they collect the sample, and again they surface, and these are collected back. And once, that is one way of collecting. Otherwise, it's just dredging. You take a heavy ring and put a fine sieve behind that one, drag it on the sea floor, and based on the size of the minerals, you can sieve can be sized actually. And if you want undisturbed samples, then we have to use corers. A corer, because of its own weight, it penetrates the bottom and collects a sample and it picks it back. There are different types of corers, tube corers and box corers. And now we have done everything, but how do you mine them? There are kinds of underwater mining machines which dwell on the sea bottom. You can have a tracked vehicle like a military tank, or it can be an Archimedes screw, it can move forward. The simple one is actually sled that is actually dragged behind a ship. This is a typical example of a crawler used by Korea. They have done up to a maximum depth of 1300 meters. And Japan and China has used the Archimedes screw, and Japan used a sled. And after having the vehicle to go on the bottom, there will be some tool to collect it actually. So you can have a passive collector. When this vehicle moves, automatically the nodules are collected, or it can be a potato like harvesting to pick up the nodules. We can have some active tool. It can be a mechanical one, or it can be just a hydraulic lift system. Once you collect it, you have to send it back to the mothership. How do you do it actually for 6,000 meters? You can have a series of buckets within a rope, and you can just circulate this rope and you can lift the mineral using these buckets. But it's not a very efficient method. It may be useful for diamonds on the lower depths, but in the deeper depths, it's a failure. Second technique is to send a shuttle, a wireless shuttle, fill the nodules with these things and then bring it back. It was not a huge success, but this technique has been really the successful in the world. That is actually to have a long riser, whether it is flexible or rigid or partly flexible, partly riser. It's called Yamano type actually. You have a pump here and you can pump the nodules mixed with seawater to the surface. And this can be done in two ways. One is by pumping air, high pressure air to the bottom and using that bubbles to lift these things. Or you can have a pump at the bottom. Again, these pumps can be ordinary centrifugal pumps, or it can be positive displacement pumps. But mostly positive displacement pumps are used in this kind of purpose because mechanical centrifugal pumps have their own problems in this. But when we do this one, there are environmental issues. Obviously, you are disturbing the seabed, which has been very dormant for millions of years. And after you bring it up, actually, again, your tailings are being put back into the sea. All this, even sediments are put back into the sea. They should not be disturbing this botanic zone, actually. So you have to take enough care for that one. So if you see the technology, so only a few countries are active in this one, and India is actually in the forefront. I'm happy to inform this August audience. And US has done a massive experiment in 1974 but for some reasons actually they have left it after putting some 600 tons of nodules. It's actually a camouflaged experiment that is mainly for actually taking out one sank submarine, actually that sunk submarine belonging to USSR at the time. Then Korea has done it at around 1300 meters water depth. Recently, Belgium has done it up to 4500 meters water depth. They have not brought the nodules up, but they have just collected the nodules. And finally, Japan has demonstrated it in their own backyard at 1600 meters water depth. For hydrothermal sulfides, they are lucky to have these things in their EEZ. But if you come to India, India has a PMN program. It has exploration, survey, mining technology, and metallurgy. NIO Goa and NIOT and IMT Bhubaneswar are involved in these things. And we got 1,50,000 square kilometers here, and we have given back 75,000 square kilometers after the survey. And we started developing a concept called flexible riser configuration, where a machine can be sent with a cable like this, and it can dwell on the seabed, it can move on the seabed and collect the nodules and pump them back. There are several advantages and disadvantages. Advantages is that actually it is one failure will not cause the catastrophic failure. It is relatively easy when compared to others. So we started taking a trawler which is belonging to one German university. We started pumping sand from around 500 meters water depth, and we demonstrated end to end. But we were not satisfied with that. We signed a contract with the International Seabed Authority in 2002. As a consequence of that one, we converted our sand mining system into nodule mining system like this. And after extensive testing, we have done it at 500 meters. There are no nodules. So we made artificial nodules and we spread them on the seabed, and we pumped them to the surface. And we are the first country to do it at 500 meters end to end. Later, our work is at 5,000 meters. So we started exploring the water column as well as the seabed. Seabed is very soft there. Whatever you keep there, it sinks in no time. Actually, it's like a grease. So we made instruments to study the seabed. That is actually how hard it is or how soft it is. It's called in situ soil tester. We used it at 5,400 meters, and we tested the soil there. And for exploring the water column, we made an ROV, remotely operated work vehicle, which is actually a exploratory tool. But for 7,000 meters, we made some concept like satellite launcher, and satellite actually, it goes to the seabed, actually it gets separated and it swims around, and when it is actually work is over, it gets docked back to the tether management system, and it is lifted back. All these three mineral resources were surveyed using this tool. And with this input, we started developing a underwater mining trawler. We estimated what are the different resistance that are come onto the trawler. So with all these things, we started developing, and we used a concept called a vertical riser system. And these are the components. This is the seabed ship systems, that is water column systems, and the seabed systems. So we sized them, we designed them, we procured them and tested them. And this is where this is the laboratory. We take it to the ship, we sit there and operate this one. And I'm happy to inform, these are some of the pictures of the machine and the seabed. Actually, I'm happy to tell this audience that recently, during the pandemic itself, we have done it at 5,270 meters. We demonstrated our mining machine. It's a world record. We are yet to pump these nodules to the top. We are also involved in the environmental impact studies of this one. With all these things, these are our future plans. By 2025 or 24, we will try to demonstrate the actually a demonstrative mining system at Indian Ocean. And whatever nodules were collected, they were given to IMT Bhubaneswar, and they were able to extract the copper, cobalt, and nickel from this thing. They made sheets. So technical viability is that, once again, I reiterate that India is in the forefront. We are actually not lagging behind anybody in this one. So commercial viability is yet to be established. The initial studies say that it's viable. Let us see how it happens. And all these things, we know that there are limitations in the autonomous systems and the remote systems. So we started making one manned submersible which can go down to these depths. These systems were earlier used by US and other countries in hydrothermal vent exploration, especially by Japan. And these are some of the components of the manned submersible. This cartoon explains what are the systems that are involved, and NIOT is involved in developing this system. Okay, so far only 5 countries in the world has this kind of system. China has added Geolong to that one. Now with this background, NIOT and MoES is involved in making a system with their broad specifications. It doesn't have any cable. It can take 3 human beings, normal human beings. No additional training is required. So these are the specifications. The critical technologies. The man ratedness is actually a very critical requirement for this one. So redundancies to be built in, and this is actually, we are in the process, almost half the process is completed. And with this, India is the only country to have all kinds of entire portfolio of these vehicles for the exploration of mineral resources of the ocean. And these are areas where India has worked from, starting from Indian coast to the Antarctican coast. We have covered everything. And this is a summary. Ocean is a treasure trove of, I'm sorry for the spelling mistake here, strategic minerals. And whereas land minerals are getting depleted, ocean mining is imminent, technology is maturing, and India is in the forefront. MoES, Ministry of Earth Sciences, is actually spearheading this effort. This technology should be technically, economically, and environmentally viable. So industry has to be involved. Expertise, equipment, environment, ecology, and economy are the buzzwords. And this I have taken from the first experiment done in the deep sea mining by US. The impossible is indeed possible when talented engineers with the courage to take prudent risks are provided as an incentive to stretch the state of the art. Okay, and before I conclude, I would like to inform you all that the Ministry of Earth Sciences is spearheading one deep ocean mission. Honorable Prime Minister of India has announced this mission, and it has been sanctioned. It has got 6 components, as you can see from here. In these, 2 of the components, that is deep sea mining, underwater vehicles, underwater robotics, and exploration. This is deep ocean survey and exploration. These 2 diagonally opposite these things are actually the verticals are mainly meant for deep ocean resource exploration. So all of you are actually invited to participate in this mission of national importance. I once again thank the organizers for this opportunity. Thank you.